Hey there, awesome physics students. Let's talk about the electric field. Now, the electric field is mathematically defined as a vector, and that's just what you would get if you take the force a positive charge would feel and divide it by the value of that charge at that point. Now, this definition doesn't really help you understand what it's about, so let's talk about what it means. What it means is this idea. What would the force be if I put a positive charge there? We're just going to ask ourselves that question over and over again, and that is the electric field. So, for example, if I have a positive charge here and there's no other charges around, the question is, what's the electric field because of this lone positive charge? I can't talk about the force because I only have one charge. And so what I do is I ask this question over and over again. I pick a location and I say, what would the force be if I put a positive charge there? So let's put a positive charge, a pretend positive test charge. It's an imaginary charge. It's not real. But what would it be? What would the force be if I put the positive charge there? Well, if I put a positive charge there, it would feel a repulsive force because of this one, and the force would point that way. Similarly, you just ask yourself this question over and over again. What would be the force if I put the charge, a positive charge, there? Well, it would be that way. What would it be if I put it here? Well, it would be that way, and so on and so forth. This is all we're doing, is we're just asking this question over and over again for different locations. Now, keep in mind, these charges are not real charges. They're just positive test charges. Everything in electricity is defined in terms of positive charges. And then if you have a negative charge, you just reverse the direction or reverse the effect, right? So if I have a positive charge here, then it's going to feel a repulsive force away. And you can't see that one because it's off the screen, but you get the idea. And you could do the same thing for negative charges too. Let's say I have a negative charge here. What would be the electric field around this negative charge? And this is a real negative charge. I can't talk about the force because there's only one charge here. So what I do is, again, I ask this question, what would the force be if I put a positive, it's always defined in terms of positive charges, there. So I put a positive test charge here. That's going to feel an attractive force, right? So the electric field is going to point towards the negative charge here. Same for here, it's going to point towards it. Same for here, it's going to point towards it. I just keep asking myself this question over and over again. That is the electric field vector. And we call it a field because it's a vector at every point in space. I just asked this question over every point in space, and that is the electric field. It's a field of vectors, or a vector at every point in space. Now, of course, I can't draw every vector, a vector at every point in space, so I just draw a few representative ones like this, and that gives me an idea. I can fill in the blanks with my mind. All right, that's what it is for those situations. Now, what about in a situation like this where I have a line of negative charge here and a line of positive charge here? Again, I ask myself, which way would the force be if I put a positive charge there? So these are two real charges. I have two conducting plates, and I have negative charge here and positive charge here. I have too many, not enough positive charge there. So if I put a positive charge here, then it's going to be repelled by this, and it's going to be attracted to that. So it's going to point that way. Again, if I put it here, it's going to feel a force that way. Again, if I put a positive charge here, it's going to feel a force that way, right? And so by doing this, I can understand what the electric field is at every point. It's a vector at every point in space. Just ask yourself this question over and over again, and you'll get the answer. Now, one final thing, the definition here tells us that the units of this electric field vector are going to be something that has units of newtons divided by something that has units of coulombs. So it's going to be a Newton per coulomb. There's another more useful unit that I want to mention that we're going to use in the future. You can also put it in terms of units of volts per meter, and we'll talk more about that later in a future video.